Well, let me welcome everyone to the CRIN carbonNEXT Carbon and Hydrogen Innovation Showcase. I'm Jason Switzer. I'm the director of carbonNEXT, a joint program between Foresight, Canada's largest cleantech accelerator, and Carbon Management Canada, which we'll hear more about, but which is a leading expert in all things to do with CCUS. Let me start with a bit of a land acknowledgement. Together, we acknowledge that the lands in which we work and live are the traditional, ancestral, and unceded territories of the First Nations, Inuit, and Métis peoples. With that, let me remind everyone that we are recording today's event, and it will be distributed to the participants as well as those who weren't able to join us today. With that, let's go to slide 2 in the event agenda. Thank you. So you'll see we're going to run through several different brief introductions, and then step into a panel discussion of a project currently being advanced between an Alberta oil and gas midstream company and a terrific hydrogen technology in the SMR space. And then with that, we'll step through 4 company showcases. So we'll have the opportunity to hear pitches from 4 different companies. We'll then go into an open Q&A in plenary, and then the companies will each host breakouts. So a fast program with a lot of great content. This is the second of 3 showcases that we're collaborating with CRIN to host, focused on CCUS and hydrogen technologies, as well as methane decomposition. And I think there's tremendous interest coming out of our last session. So we're really thrilled to be able to share these terrific companies and their stories with you, as well as give you some insight into the theme. Next slide, please. Oh, there we are, CRIN carbonNEXT. Thank you. So, you know, a key area of focus for us was really to engage oil and gas producers and energy service companies across the oil and gas innovation ecosystem in Canada with pre-commercial technology developers in carbon capture, conversion, hydrogen production, methane decomposition, and related areas. And again, the next session will be coming up in April. Next slide, please. And last, just to say that this webinar is hosted by CRIN and carbonNEXT, and carbonNEXT is an initiative of Foresight and Carbon Management Canada. Next slide, please. Thank you. So let me just talk a bit about carbonNEXT. As we know, all credible, cost-effective pathways to net zero include CCUS in some form. Some estimates suggest we'll need between 2 and 10 gigatons per year of CCUS and carbon removal by around 2050, which would make it on the same order physically as the global oil and gas industry is today. We need more and better, cheaper tools to prevent CO2 from entering the atmosphere and to pull the CO2 that's already accumulated there out and out of our oceans, and to put the CO2 into long-term storage or into things that people use and to ensure, of course, that the CO2 stays there. So building on Canada's early leadership in CCUS, carbonNEXT seeks to streamline the commercialization journey for innovators and industry partners across the set of technology areas for CCUS, or as we like to refer to it, carbon tech. We leverage the country's largest pipeline of emerging clean tech solution providers through Foresight Canada. And Carbon Management Canada provides valuable knowledge, connections, access to testbed facilities, and experience supporting industrial emissions reduction solutions and commercial deployment. Let me just confirm, has David Van Essen been able to join us, or shall I continue on to introduce CRIN?
I'm here.
Hey, terrific.
But
thanks,
you're
David.
doing a great job, so carry on. So would you like me to take this?
Yeah, please. Why don't you introduce CRIN for us?
For sure. So many of you are already familiar with the Clean Resources Innovation Network, and we're very grateful to have folks like Foresight supporting some of the initiatives we're trying to to get out into the market, namely, building the community, building the awareness, and connecting every part of the ecosystem together. So be the network that allows the networks to exist and thrive. So CRIN's priorities are for addressing some of the big environmental and economic challenges that we currently face. And today you'll see some of the shining stars of examples of how to get there. And there's a number of technology theme areas, and it covers a number of different sectors. There's quite a few members. I think that slide is outdated now. I think it's probably over 3,100 members now, so and growing, which is fabulous. The focus area, the technology theme area that today's discussion fits in is the low emissions value add products category, which is it's a mouthful, but obviously hydrogen and CCUS are crown jewels in that group. Next slide.
Thanks, David. And I think with that, we'll pass it over to Jeanette.
Good morning, everyone. Welcome to this session today. I think there's going to be an impact of information for everyone to absorb and reflect on. My name is Jeanette Jackson. I'm the CEO of Foresight. As Jason mentioned, we are Canada's largest clean tech accelerator, and we're very excited to ensure we take a whole of ecosystem approach with industry, academia, government, and investors at the table to more effectively guide our Canadian innovation and entrepreneur communities that are passionate about climate and sustainability. We've also been delighted to support CRIN in the value add stream. I look forward to seeing some of the presentations today. And of course, maybe this is a nice segue to Stephen Lougheed. We've partnered to launch carbonNEXT as a focused initiative on positioning Canada as a global leader in the space. There is so much competency and opportunity here, and we're just delighted to take a very collaborative approach that will create a network of opportunities for, again, those stakeholders that I mentioned. So have a great session today, and perhaps I'll segue it over to you, Stephen.
Great, thanks a lot, Janet. I just wanted to welcome everybody here. Thank you to CRIN for hosting and organizing. The partnership between Foresight and Carbon Management Canada is very important in terms of supporting the acceleration of businesses and connecting them with a lot of what we do at Carbon Management with the larger emitters who have the demand and the requirements for some of these solutions. Won't get into much detail because it's all there on the slide. You can go take a look at it afterwards. Just very much looking forward to seeing the companies that are being showcased today and our future events that we're going to be having with CRIN. Thank you very much.
Terrific. Well, thank you both, Stephen and Jeanette. And with that, we're a few minutes ahead, which is terrific. That'll give us a bit more time for our panel discussion. I know that was a highlight of our first session. So our panel discussion is intended to provide a bit of insight for our attendees on how some of these partnerships come about. Our previous session covered Synovus and really Husky's early work in partnership with Svante, a carbon capture technology developer, to collaboratively advance the capture solution that Svante had been developing and employed specifically on an oil and gas asset. This morning, I'm really pleased to present Brett Whiteman, who's the manager for energy efficiency at CSV Midstream, a midstream natural gas and liquids infrastructure company based here in Western Canada, along with Jan Boshoff, who's the co-founder and CEO of New Ionic Technologies, which has a novel methane reforming technology that produces teal hydrogen. So with that, let me ask both of you to just wave so that everybody can see you. And Astrid, I'll assume that we can position both Gary both Jan and Brett in such a way that they're going to kind of be the primary screens that people will view. And I'll just ask maybe Jan to kick us off with an introduction and a bit of an overview of your company, and maybe you can tell us a little bit about what teal hydrogen is.
Yeah, no, absolutely. Thank you, Jason, for the introduction. And New Ionic is a company that was founded in 2016, really by a group of engineers, a lot of guys formerly out of Atlantic Hydrogen, a pyrolysis company in the Atlantic region in Canada, with technology in the plasma pyrolysis of methane. And I'm formerly from South Africa, used to work for Sasol for most of my career, and really was looking for a way to decarbonize natural gas reforming. And we came together as really a group of technology experts and say, what can we do to advance the utilization of electricity in the industrial complex? And really took a hard look at industrial microwave as the platform. And that was the birth of New Ionic. And so we are commercializing novel applications of industrial microwave technology, really towards advancing low carbon energy sources as inputs into the industrial setting. And our first technology is teal hydrogen, as you mentioned, having extensive experience with pyrolysis and taking a hard look at the need for distributed scale hydrogen production. In our assessment, CO2 was the preferred byproduct for small scale hydrogen. And so what we do is essentially eliminate the most polluting components of natural gas reforming by electrifying that part of the process. The result is 30% less natural gas as input into the reformer in equipment that's literally 30 times smaller than a conventional reformer. It's a highly efficient conversion process and enables small scale hydrogen production in ways that enable you to produce low carbon hydrogen with a very low fossil fuel demand and extremely low carbon footprint. Our teal hydrogen, teal is what you get when you blend green, and blue. That's in our logo, and it's green hydrogen mixed with natural gas as input gets you 85% of the emission reduction compared to gray hydrogen production, and that allows you then to produce that hydrogen by only purchasing a quarter of the renewable electricity than you would have needed for electrolysis. So we think this is a very suitable and appropriate technology that enables us to advance the adoption of hydrogen in the industry and still make use of our existing energy infrastructure. So that's kind of the background of the company. We've been at this now for about 2 years, getting from pilot scale. We're now looking to scale up our reactor concept from pilot to commercial scale, and looking at a number of commercial demonstration opportunities. We have 4 identified during the course of this year and early next year in the production of highly carbon negative green hydrogen from biogas, as well as decarbonized fuel gas and pipeline injection projects. So very excited about some announcements that we will be able to make during the course of this year for the demonstration and implementation of our technology. That's kind of the background, and I think I'll let Brett go ahead and take some of the floor.
No, that's great. Thank you for the intro, Jan. And just a reminder, green hydrogen being the renewably produced, or I guess really speaking to electrolysis driven by renewables. And of course, gray hydrogen being the traditional steam methane reforming without CCUS. There's so many colors and so many ways that people talk about it, and so it's helpful to have that introduction to teal the way you framed it, Jan. Brett, let me turn it over to you. Maybe you can tell us a little bit about CSV Midstream and in particular about how innovation in hydrogen fits specifically into that broader strategic plan for CSV. Thanks.
Oh, thank you, Jason, and thank you very much for having us here today. It's exciting to be a part of this, and you can just hear Jan's passion, and that's certainly one of the aspects that we look for when we're working with companies like his. But yes, CSV Midstream, we are a midstream employer base for the moment, and our focus really, and part of my role is the CSV part, which is creating shared value. It's a Michael Porter Harvard business principle where using a kind of a profit-minded business model to help solve social problems. And that's where I get to add CSV to our projects, both the new ones that are up and coming, as well as the existing ones, trying to improve the value to the community by our products, our our projects, as well as strengthening our vendors, the supply chains, and maybe more importantly, especially to our producer customers, is that we're bringing them solutions that are enabling them to bring better products to their customers as well. And that's where, you know, we use innovation to help advance midstream. We want to be a leader in that, and we want to help advance the industry. And that's part of our reason for being in part of that. You know, H2 has a specific use. Steam methane reforming is like Jan just said, is a more carbon intense measure to do that. So there are current needs today in society where, for example, I think the example given was in partial upgrading. There is a need for that. We'd want to certainly look for a means of lowering that carbon intensity, as well as we feel for the future trying to bring lower carbon intense plants for our customers to be able to enable them to produce their product for a lower carbon intensity, as well as a future lower carbon intensity energy form. And so trying to be creative and looking for ways to do that. So that's where we need this sort of relationship and partnership, and really look forward to what comes from them.
Terrific. Thanks, Brett. Well, let me maybe put it to you, Brett. How, I guess, you know, the when Harry met Sally kind of journey. So I wonder if you could share with us a little bit about how you came to engage with New Ionic.
Well, certainly I give a shout out to CRIN and talking about the value of networking. And I hear in so many aspects, there's people talk about it being challenging to become connected, and I will reinforce the importance of networking and being involved in these groups and sitting on these panels and following up afterwards too with the people that you see and hear from too. But it was exactly that. I think there was a CRIN calling for a project, and we were looking for technologies that were aligned with the calling. And so I think it was specifically Initech Alberta Initech, who I was asking about technologies that suit the bill, and they were able to fit me with New Ionic. I think specifically, for us to give some highlight to, we really need a company that's probably closer to being near commercial. We are looking to implement something in the next kind of year to 3, and really want to start kind of engaging and providing feedback to them as they're drawing towards that commercial stage, so that they can improve their offering to the industry. Because I know from my own innovation background early on, you can certainly try to solve a problem that may not truly exist. And so we're looking for some companies that have some traction, that are near commercial, and that are ready for some exposure to industry. And that's where the stage of New Ionic was, and that's how that conversation started.
Well, let me turn it over to Jan and to say, Jan, okay, so how did CRIN come up on your radar, and in particular this collaboration with CSV?
Yeah, no, I think I'll echo Brett's thoughts around the strength and the benefit of networking. Certainly the folks at Initech Alberta have been very helpful for us in coming up with connections and solutions to say, how do we position and get you guys in front of the right people in the industry that might be users of the technology. I think one of the challenges for a technology development company, especially one that is technology heavy, such as ourselves, we're a company of engineers, is that a lot of times I think we fall into that trap. We invent, engineers think something is valuable because it's difficult or hard to do, and in reality, something's only valuable when it has economic value. And I think, like Brett mentioned, the proof sits in the pudding when you get something in front of the market. And I think Alberta Initech really has been very helpful in making connections. I think we're a solution, and many of these hydrogen technologies that are emerging, I think we're going to find that the market is huge. There is not one solution that is going to fit every single situation out there. And so it does require a tremendous number of conversations and discussions, and getting to know what does your customer really look for, what do they need, and is what you're doing a fit for them, and rather trying to fit a square peg in a round hole, find the places where there's a natural fit and attraction, and then you can go. And so I think that's kind of the background really with networking. CSV found them to be extremely open and entrepreneurial, and willing to live with some of the ambiguity that's inherent in a startup, around timelines and around when we will have what kind of solution. And that's been extremely helpful from our point of view.
Awesome. Thank you so much. Well, and I guess, the obvious question then comes, and this will be of great interest both to the energy producers, the midstream companies, the energy services companies who are whose members are joining us today, as well as to some of the entrepreneurs. But I wonder if we can, if you wouldn't mind sharing some insight into some of the challenges that have emerged as you've been going forward. And maybe I'll put that to Brett first.
Yeah, and I sometimes feel that we create the challenges as much as they just kind of happen. But really these relationships take a long time. I think about transistor development and things taking decades, but the advancements of these technologies can take a long time, both in the stage from Nuonic side, but also in trying them out on in a near commercial stage to get them to a point where we as a company can go forth to our investors and say we have confidence with this to the tune of some large dollars, and we're ready to deploy that, and we need to put that hand up to tell our customers that indeed this is going to work. And so that is a long time scale, and that long time scale, many things can happen. And so it does take a good amount of patience and understanding, and not to be, to be honest too, we look at many different technologies through the way, and some of them over time filter out, and either our requirements change, or we find that the technology just doesn't do what's needed, or sometimes there's just a competing technology that can outperform and provide a better solution than one too. So that's certainly a large aspect of that. But throughout that process, we are communicating back and forth with not only what we see with this technology, what we need from it, but also what we see in other technologies too. And so as much as those challenges become obstacles to work around, they are also opportunities for the benefit of both the technology provider as well as industry.
And yeah, and I guess from your perspective, and often, and of course, you guys are not based in Canada, so there are some unique challenges there as well. Can you speak to some of the challenges that you've kind of perceived, and how those have been, how you guys have managed those?
Yeah, let me just clarify. New Ionic is based in Canada. We're a Canadian company out of New Brunswick in Fredericton, New Brunswick. And I, on the other hand, I'm on the other side of the border. I live in Tulsa, Oklahoma. And when we started up the company was right when COVID hit and the border shut down. And so we've learned to have a virtual working relationship, and it's been to our benefit in the end. So
my apologies.
Yeah, no worries. Yeah, so yeah, I would say, Jason, I think the biggest challenge in my experience is just aligning the stars, and for some of it, it requires a lot of heavy lifting and a lot of work on the company's behalf to make sure that the stars align for you. And in many other ways, it's really just timing and finding the right people that you can connect to that will run with and that sees the value in what you do. And I think that's the most challenging thing for a startup that have limited resources, limited time. I mean, everyone's wearing multiple different hats, and so you can pick to work on 5 different hot topics every single day. And the key is, how do I ensure that when a grant application, the timing for it aligns with when I will be ready to actually advance the technology for what the grant requires, if I'm looking for non-dilutive funding, and that I can convince a customer, based on what I currently have done, that it's worth for them to support this technology and host a demo or put some resources behind, a first demonstration. So I think yeah, that's the most challenging and the hardest part. If anyone has solved that issue, then please contact me, because we're still working through that. There's too many things that you need to have in the air and balance at the same time.
And I guess now, as things are moving forward, you're of course waiting on the result of the CRIN competition. I wonder what are some of the challenges you see moving forward that will emerge as you start to put steel in the ground, presumably.
Yeah, I think let me just, from our side, I think the challenges we see is really finding the appropriate demonstration facilities that have the right level of funding support, that de-risks it sufficiently so that it's a win-win both for our investor as well as for the customers and the funding agency. That what we are doing is a fit, that we can clearly articulate the value proposition. And in some cases you don't get all the grants that you apply for a number of different reasons. And so sometimes the timing isn't right. You haven't done enough background work, or you're not exactly what the grant is looking for. It's not the flavor of the day. And so, then it's a matter of navigating, how do I work with perhaps less, the non-dilutive funding that I anticipated and invest more equity capital on a demonstration. And I think it's a lot of times the balance between schedule, getting out into the market, commercializing my project. So, I think for us, the real challenge is how much do we do, how much do we slow down and be capital efficient in order to leverage the maximum amount of non-dilutive funding versus throw resources behind it in order to get to the market quicker and have a product that we can offer to customers. And that is a challenge, because a lot of times we create expectations around grants, and if you don't get a grant approved, then you got to retool. And I think in working with partners, sometimes their priorities shift. And so having a backup plan for a demonstration site, if a partner's priorities have shifted or, something has changed in timelines on their end, and by the time that I'm ready to host the demo, my customer may have moved on to either, they've got a different flavor of the day. I have a new challenge in some changes in management, or the person that was our contact is no longer there. And so it's just creating, making sure that we have sufficient plan Bs in order to advance the technology for the runway that have been afforded to us by our investors. And so I think that's the challenge that I feel like a day by day that we deal with is surviving one more day with the runway and ensuring that we gain traction, that we advance the technology while also getting significant increase on the uptake of the technology.
Thank you, Jan. That's also very honest and insightful kind of window into the startup journey in this space, and how difficult it is in hardware-oriented tech like yours, right? Let me turn that question to Brett, and then I see we've got a few questions coming in from the audience. Brett, one of the challenges that really comes through from what Jan just said is that syncopation between the startup timeline, which has to move fast given the limits of both non-dilutive funding and equity, cash, and expectations of investors and limited resources. So, and generally the kind of pace of oil and gas or large corporate decision making has been slow traditionally, and in particular challenged by I think we all remember March 2020 when the global economy kind of downshifted by about 3 years. What do you see? How have you guys managed that kind of time cycle between the decision making within CSV and the timeline of a company like New Ionic?
No, you've outlined that very well, and those challenges do exist. And I know, I relate my challenges in my world compared to Jan's, and they are relatively simpler, but they do still exist. And yes, our customers have changes. Our company only has so many resources too, so there are certain things at certain times that we can chase down. And yeah, it is a long attention span cycle through there. We as a company, again, try to have many plan Bs, if you will, and try to keep as many irons in the fire as we can without leading too many people on, and trying to be open and honest about that. Communication is very important in that too. It's also, I have to get the project to the point in my management that it's de-risked enough. So I'm also constantly aware of, putting challenges out in front of the technology companies to show and demonstrate, and to leave a bar set for them to hurdle against, so that we can take this relationship that we've been nurturing over the course of the years and kind of deliver them to the promised land, and have that be there and be leveraged. It is yes, stars have to align. You have to have lots of communication, lots of plan Bs. And even from our group too, we try to maintain a consistent matrix of how we evaluate these companies, to try to be true to our values and our goals. But those indeed do change over time, and certain things that were important at one point become less important as we go to chase others. So it is the risk mitigations to that is to have many plan Bs, to have many conversations, to have lots of good communication, because like you said, Jason, you just can't predict the future. And yeah, the stars need to align. The future needs to be somewhere that's you can play in, and the timing aspect needs to be there too.
Thank you. Well, a few questions come up in the chat that I'll sort of aggregate, and they're all for Jan. So one was around your TRL and the timeline you envision for commercialization. And then a follow-on question for you around who you see as your lead customers and beachhead.
Yeah, so TRL is always a subjective number, and I always wish I can say 8, and I'm always pulled down. I think we, on an objective basis, we have piloted the technology at a scale that is representative of the commercial scale. And so, that's a TRL 5 or 6, depending on your interpretation of the technology and the technology readiness framework. We're now looking for, we have one scale-up step remaining before we are able to package the reactor into large tons per day units, and we're looking to deploy a 1 ton per day demonstration plant starting next year. And in terms of target customers, we're in advanced stages with several companies. We have letter of intent with a large multinational chemical manufacturer for decarbonization of their fuel gas, and basically producing low carbon hydrogen from natural gas for use in fired heaters and kilns behind the fence. And that demonstration is lined up in the US for 2023. Also are talking to a very large developer of landfill gas in California for negative carbon green hydrogen production into the mobility market and California market. That also is scheduled to deploy next year. So very excited about those 2 projects. And then we have several other in the pipeline. We really have probably scope within the company for 2 more options. One, the front runner for us is a demonstration in Atlantic Canada for injection into the natural gas grid. And then we're excited about a project we're doing with Innotech Alberta to host a demonstration, in Alberta, as with the objective to optimize the integration of carbon capture into that. So that's kind of a long answer. I think key in terms of customers right now, I think that's part of the challenge for a startup like us. We have a great solution, with a niche application. I think Brett and at CSV, what we found there was just people that are open to say, look, there are multiple ways in which to skin this cat and in which to approach the business model here. If I could pick, I would rather just sell the proprietary equipment that we produce, and only sell that hardware. And a company such as, in the midstream space that's familiar and comfortable implementing, plants and putting infrastructure into place and owning and operating that equipment is a great potential partner, because it allows us to focus on the technology solution, and the operational challenges associated with building and operating units. We then rely on partners that's their bread and butter. In other cases, and this is certainly true for some of the demonstrations that we're doing, we are actually taking a ownership stake in the plant, building a demonstration facility and providing the services for converting that feedstock into hydrogen. And so, yeah, there's a number of different ways in which we're looking to skin this cat. Mostly, long term would be providing technology solutions, proprietary equipment licensing for the technology.
Awesome. And maybe I'll ask you to make a quick answer, and then I'll turn it to Brett for a response as well. But Jan, how are you choosing what business model you go ahead with, and how does that kind of align with or contrast with your shareholders' perspectives as well?
Yeah, I think that there's a capital light business model, which is selling equipment that requires the faith from your customer in a new technology. And then there's a more capital intensive business model that requires you to put the equipment in the ground and build and own and operate them. And so in some ways, I would say the choice is really driven by the customer, their willingness to accept risk, and the value then to the startup company and in engaging with that customer. For a large strategic customer, the way we're approaching this, just to be transparent, is in some cases we think it's going to be beneficial for us to collaborate with large strategic customers in very specific markets to deploy our technology and actually take some skin in the game in the demonstration. And does that mean that 5-10 years down the road that's still the predominant model in which we engage with that customer? It might not be. Eventually, I think we would like to transition to supplying the technology and focusing on where our strength is. But my background is in operations, and I've run a facility that was 24/7 operations, small scale plant, a lot of comfort with what it takes, to build an operating unit and how to prepare and staff and commission and run it. And so, I think we're keeping optionality open at the moment, but the choice for us is really driven by the amount of capital, that's at disposal. I think if there's more margins to be had if you are able to build, own, and operate, but it requires building a bigger organization, and being strategic about, geographically where you start out. They can get to a much larger market quicker if you're able to supply into, equipment into key other off-takers. And so, I would say we're exploring both, but looking down the road, 70% of our revenue most likely will come from technology supply, and equipment.
Thank you, Jan. And Jana, I'll extend an invitation to you on behalf of the organizers. It was our oversight earlier, but if you're interested in hosting a breakout following the 4 pitches from the SMEs we've invited to join us today, we'd happily make that available for you.
Sure. Yeah, I would love that. Yeah,
I'll allow Astrid to reach out to you offline to set that up if that's of interest. With that, let me turn it back to Brett and just ask you a similar question. How did you make the business case for this project internally? Were there particular motivations? Was it part of investor push around ESG? Was it part of your transition, your net zero planning? Or something uniquely associated with either the hydrogen hub push in Alberta or the emergence of the clean fuel standard? What are some of the proof points that allowed you to get this over the line with your executive team?
Yeah, certainly. And it's, you know, I will say too, to tail into to Jan, you know, we are a capital intense business. And so that's why we like to pair with them. I'd rather have the technology companies spend their money on developing the technologies. And we certainly look for to bring the capital to help continue that deployance. And as we look to the better ways of deploying our capital, certainly we look at future risks and you know, understanding and communicating with our customers and what they see and hear, and you know, lots of them are talking about carbon neutral in 2050, and so we are trying to find the best solutions to help get them there, help get us there. You know, it isn't a, you know, yes, we do have some shorter term in the next, say, year or three specific needs for hydrogen, but there is definitely a longer term plan here. You know, when I look at business economics too, you know, at this stage when we're still early in the game, I am dealing with a decade or two of, you know, will this technology get us close to a 10 or, you know, 100, maybe a little bit of a stretch, but certainly if something's 100+X out of where I think it can be, I'm probably not going to be paying much attention to it. But, you know, there can be some changes in the future with fuel standards and things that might create a 10X cost difference to the way that the market is today. And, you know, 10X is certainly within a technologies company's lens, and to say that the economic scale for us to pursue them. But then there is a core of technologies that are within arm's reach of getting us to where we think we need to be economically. But certainly there's the technology risk for sure. But you know, like I started with creating shared value, there's a profit-minded sense to all this too. And as much as we really focus, and I really focus on creating value and bringing benefits to helping advancing midstream, bringing value to the community, I also have to be mindful that those technology solutions have to stand on their two legs. And if they do, it's great. They will self-replicate and expand with, and maybe even at a later date without government incentive. But you know, I certainly have to take a broad look at where they are. Are they close to reaching that? And if they are, then yes, I will give them attention. I will help work with them to work towards a solution that is going to be economic at the end of the day.
Terrific. Thank you, Brett. With that, you know, we've kind of come to the end of the time that we have available for this wonderful panel discussion. So please join me in thanking both Brett Whiteman and Jan Boshoff. And I'll just point out that CSV is doing some great work with a number of innovators, and just share a plug for them, as well as a plug for a number of the initiatives that we have underway. One, a partnership with Unique Ventures, who are on the call today with us, to accelerate emerging oil and gas transition technology providers through a program called EnergyNEXT. With that, that really draws this panel discussion to a close, and we now have the opportunity to feature a number of presentations. Please hold your questions, of course, for Jan and Brett. You can certainly follow up with them after, and I'd encourage both of them to offer their contacts, and hopefully Jan will be able to set it up such that Jan will be able to join us for the breakout subsequent.
Thank you.
Let me ask that Astrid or Lee, if you wouldn't mind just putting the slides back up. We are now going to have 4 pitching companies: NewWave Hydrogen, Ekona Power, Hydrogen in Motion, and Aurora Hydrogen. And so with that, let me each of them are going to have about 5 minutes to present their technology. At the 4-minute mark for each, I will indicate by holding up my hand the time is running out. So please keep your questions towards the end, where we'll have about 35 minutes or so for a moderated Q&A. And again, happy to grab questions from the chat, and that'll be followed by breakout rooms with each of the ventures, which will last for the remainder of the time that we have blocked today. If there's any questions for the presenters, again, please use the chat. And with that, let me invite Kathleen O'Neill, CEO of NewWave Hydrogen. Very interesting technology. You're up first.
Hello. It's very nice to meet you all, and I appreciate being here today. Let me see if I can share my screen and get this set up. All right. Can you see the screen?
Yeah, we can see it, Kathleen.
All right, thank you. So I'd like to present today a new wave in hydrogen, and the wave refers to a supersonic shock wave or compression heating via shock wave heating. And what we do is we leverage the pressure already inherent in natural gas pipelines. And this means low external energy requirements and maximum use of existing infrastructure, which we think is important for a rapid hydrogen transition. So as most of you know, steam methane reforming is the predominant production method for hydrogen, but it has some drawbacks and some barriers to the hydrogen transition. The other main component or technology is electrolysis. Both have significant water uses. Steam methane reforming releases CO2, and mostly both of them have a co-build out requirement or a dependence on investment and co-build out in associated infrastructure. For SMR, it's associated CO2 pipelines and CCS or carbon storage locations. And for electrolysis, it's reliant on a very massive build out of renewable power. So what this leads to is long time lags actually in implementation because of the codependence on investment in other infrastructure and high infrastructure risks, and in some cases geographically limited implementation. Just quickly, this is borrowing a slide from BASF, comparing SMR with electrolysis and then with methane pyrolysis. And as you can see, SMR, the drawback is it releases CO2, about 9 kilograms per kilogram of hydrogen. With electrolysis, it has a very high electricity demand, at least in this implementation. And if that electricity isn't paired with renewables, if it's using conventional grid electricity, that means a very high CO2 impact. Whereas methane pyrolysis really has the best of both worlds, where there's no direct CO2, no water use, and a relatively low electricity demand. This is a snapshot from one of the hydrogen roadmaps. I think it's the European roadmap. In this, most of them that I've seen rely pretty heavily on SMR with CO2 and electrolysis for the projections. And they don't really emphasize the co-investment requirements, but they do show the lag. So what you see here in the green is about 40 more years of business as usual with SMR emitting CO2 emissions until the CCS and CO2 pipeline infrastructure can catch up. And similarly with electrolysis at the top, this blue wedge, it's really the lag in sizable rollout is potentially due to the reliance on co-investment in renewable power development, and not just to meet the current demands or projected demands in power, but to meet a multiple. So you have to have a multiple of investment in renewable power to power the hydrogen production technology itself. So what we're hoping for is a new wave in hydrogen production, and we hope that we can directly address these limitations or these barriers to a rapid hydrogen transition. Our technology is based on an existing technology, actually, wave rotors. Wave rotors have been around for about 50 years. They're well known. They're known to heat gases to temperatures sufficient to directly crack methane into hydrogen and carbon black. So our innovation is not...
So sorry, just want to give you the 1-minute warning.
Thank you. Okay. So our innovation is not the wave rotor itself, but it's in the application of the rotor to hydrogen production. And the wave rotor can be conceived as a rotating bank of shock tubes, essentially. I think I'll just skip. And the reasons that we believe we can lower the barriers, what's really unique about it are some of the unique differentiators of wave rotors themselves. They're highly scalable. So we can scale to micro levels all the way up to large scale centralized hydrogen production. We have very efficient energy use because we don't use electrical energy to drive the reaction. It's driven by shock wave compression. We have a number of really excellent partners that we're very proud to be working with. We have co-funding from Emissions Reduction Alberta, ERA, from the Natural Gas Innovation Fund, from Total Energies and GRT Gas in our current project. And we have 10 of the leading Canadian oil and gas producers and distributors supporting the project under IGIF, as well as Global Indigenous Group. We're very happy to be working with them. And we recently added Stanford University and NREL, and we have a number of really excellent Canadian universities and engineering partners. So we are focused in the current project on developing a pilot demonstration, and we have also submitted some recent patents focused on ammonia to hydrogen conversion, as well as on integration of our system with power turbines. So what we hope is to break the barriers, accelerate the transition, produce low cost, scalable hydrogen, and mostly to allow a rapid route to GHG reductions to really accelerate the process. So thank you. I appreciate your time today.
Many thanks, Kathleen. And of course, folks, you'll have the opportunity both to ask Kathleen more questions in the Q&A as well as during the breakouts. And with that, let me invite Gary Schubach from Ekona Power to join us.
Thanks very much. Let me just share my screen. Hope you can all see that. It's a pleasure to be here today. My name is Gary Schubach. I'm with Ekona Power. I'll try to be brief and go quickly. Ekona Power, who are we? We're a company that's developing scalable, low-cost technology for clean hydrogen production. We're located in Vancouver. Our formative investors are Evoke Innovations and iBet. And late last year, Baker Hughes and BDC invested into our company. That was publicly announced. And then most exciting, yesterday we announced the close of our Series A financing round, and a very exciting group of syndicate investors coming into the company to help us through to commercialization. So we're very grateful to them. And we're also very grateful to the government funding agencies that have worked with us over the past 4 years since our inception to get our technology to the state it's in today. So a lot of great partnerships. We're grateful for those. The markets we're addressing are, well, we're a hydrogen producer, so we're going after hydrogen markets. And you know, what's really exciting about that is hydrogen is a growth area, and particularly in new market areas like transportation, industrial energy, building and heat, power, where, you know, decarbonization is a challenge. But for hydrogen to have maximum impact in these new markets it needs to be cleanly produced. And, you know, we look around, and I agree with a lot of the comments the previous presenter made about hydrogen production, steam methane reforming, industry standard North America. But when we adopt CCS, it adds cost. And when we look to, you know, electrolysis as an option, very compelling in terms of greenhouse gas emissions, but electricity intensity can make it very costly. And relying on, you know, conventional grids can make it highly emitting. So when we look at this landscape, we think there's a new solution. New solutions are needed that can address clean hydrogen production that don't add cost. And that's what we're about. Our product, we call it the PMP, pulse methane pyrolysis. It's a novel way to pyrolyze methane. What we do is we use the energy inherent in the combustion event to crack the molecule. Our cartoon reactor on the left shows two separate chambers, one where there's a combustion event occurring, and then we inject the results of that combustion event into the feedstock chamber, where rapid mixing, high-speed gas dynamics in a constant volume process raise the pressure, the temperature of that vessel to a place where the contents pyrolyze. Out of that reactor comes a soup of hydrogen, carbon, CH4, CO2, water, et cetera, and that goes to downstream processing. Now, when we think about scaling up this reactor to something meaningful for industry, we think of multiple tubes. We think of these multiple tubes being fired in sequence, and our concept for a 100-ton per day reactor you'll see on the right. So that's how we see this technology scaling, with valve assemblies that time each of these reactors. And in a lot of ways, it's a lot like an engine. The process itself takes that reactor and then does a bunch of things to it that are highly conventional. We separate the carbon out, we separate the water out, we separate the hydrogen out, which is what we want. And the rest of it goes back to the reactor for further processing. Carbon and water are also produced, potentially very valuable to this solution if we can harness the intrinsic market value for carbon. What's the value proposition? Low cost and clean. We feel that if we're successful scaling this technology to industrial scale, it'll compete very well in terms of economics with conventional steam methane reforming, and at the same time reduce greenhouse gas emissions by 90%. So, we have a lot of work to do to get there, but methane pyrolysis has a great deal of promise, and I think this event today recognizes that. Where are we? Well, we're admittedly early in our development program. We've completed our proof of concept work. So we've built a proof of concept reactor, tested it, validated the principles of this post-combustion method. We're in the process now of scaling up that reactor to a pilot scale, 200 kilogram per day commercial intent design. And that is being fabricated presently in our Burnaby-based facility, where it'll be tested this year in a brass board system. From there, we'll be scaling up this technology to a full demonstration system where it will demonstrate the entire integration of this platform and then move to pilot. Our go-to-market plan is to execute that program, demonstrate our pilot with key partners, develop, build, own, operate models, and eventually license the core technology to accelerate its adoption globally. So we're excited about where we are. I want to thank you for your time listening to me, and I am done. Thanks.
Bam. Thank you. Closed around and landed a pitch in under 6 minutes. Thank you very much, Gary. With that, let me turn it to Grace Kwan, CEO of Hydrogen in Motion, another BC-based hydrogen company that's doing great stuff. Grace?
Hi, thank you. Let me share my screen. Bear with me for just a moment. Screen. Okay, well, Hydrogen in Motion. I was the former senior advisor to the CFO of the Treasury Board. Prior to that, I helped manage a $250 billion budget. My budget is considerably smaller right now, but it won't be forever. So Hydrogen in Motion, the reason I founded it was to address one of the key issues in the hydrogen economy, which is storage. What we've done is we've developed a nanomaterial that stores hydrogen under low pressure. So essentially we make a smaller, safer, cheaper tank. And that's it in a nutshell, our value proposition. So we're early stage. We're just seeking commerciality with scaling up from TLL 4 or 5 to TLL 8 this year. And we are scaling up our production of our nanomaterial. And we see it being used in sort of 3 major ways: to transport and distribute hydrogen, to improve fuel cell refueling, or to store energy generated from other sources. So our breakthrough technology is the key to the hydrogen, opening up the hydrogen supply chain, and we'll be growing the global market for hydrogen technology and hydrogen-based storage. The next slide is about why do we need this technology. There's very few stations. Stations are about $2 million each, and the cost of high pressure and storage represents 30 to 50% of the cost of your fuel. So at $12, your $4 to $7 represents storage and transport and distribution of your hydrogen. So it's very expensive. We can bring that down. We can have that cost, and that's our value proposition. Just looking at our technology, it's a solid state hydrogen tank. And then if you look at where we're going with this is we want to become the default tank of the future. So I see Jason is eyeballing the time. I don't want to take up too much of your time. I'll leave the rest of questions for the breakout room. You can contact me at grace.kwan@hydrogenemotion.com. And thank you for your time, and let's have a conversation.
Thank you so much, Grace, and really grateful for the additional time you've saved us. So let me, with that, hand it over to Andrew Gillies, CEO of Aurora Hydrogen. Andrew.
Hi, everyone. Just the requisite, you're able to see my screen? Great, thank you. Okay, so we are Aurora Hydrogen, developing a novel methane pyrolysis technology. The way we see the current problem in the space, I mean, I'm not going to tread over ground that's been mentioned too much, but you know, we see this gap here in the availability of a low-cost, distributed, and scalable hydrogen technology. Because right now, you can get low-cost hydrogen, but it's centralized from SMR facilities, and you can also get distributed hydrogen, but it's quite high cost via electrolysis. And we're not seeing either of these general technology groups enabling a lot of the hydrogen use cases that are envisioned, be it natural gas blending for heating applications, be it transportation. And we think that for these hydrogen fuel cases to be enabled, we need a low-cost distributed technology. So I'll explain how Aurora fits into that. What we're doing is we are driving a pyrolysis reaction using microwave energy. And for people familiar with the methane pyrolysis space, we are not using a plasma. This is not a microwave plasma. We are also not using a catalyst. What we are doing is directly heating the carbon product with microwaves using a novel method that is extremely energy efficient. So what this allows us to do is produce hydrogen with less than 80% of the energy required from electrolysis, and we believe lower energy than any other proposed or existing methane pyrolysis technology. And what that does is put us in a low cost position without taking any carbon price into account, we believe, relative to any proposed or existing hydrogen production technology. So that hits the low cost side of the equation. Now, if we're talking about distributed and scalable, this is again where we leverage microwave technology, which is inherently modular at a smaller scale. And then there are different types of RF technology available for efficient scale up. We are using a reactor that we can operate under pressure, so we don't have to increase the footprint to scale up. We can increase pressure to 50, 100 bar while adding additional microwave energy to a single reactor. So we believe we can have an economically viable reactor from a capital cost point of view that's competitive with an electrolyzer around 200 kilograms a day, which could be an appropriate size for, say, a fleet of 10 buses. And then we believe that we can access economies of scale as we go up to hydrotreater scale and beyond. Another interesting, two interesting points I'd like to bring up. One is that the process using microwave energy can come up and down quickly. So we believe we can use our technology as a load leveling device for intermittent renewables, where we produce hydrogen at peak renewable, and then that hydrogen can be bled back into the grid through hydrogen or hybrid electricity turbines, for example. The other point worth mentioning, I mean, there was talk earlier about green, gray, blue, turquoise, which can get a little bit muddy. But making a comment about our relative position from a greenhouse gas emission point of view, we used the NRCan tool for assessing clean fuels, GHGenius, and found that because of our extreme electricity efficiency, if we use average grid energy, in Canada, we have approximately 30% less CO2 emissions, overall GHG emissions than electrolysis, and that includes upstream methane. And if you look at the US average grid, we're about 60% less, and Europe about 50% less. So, do what you want with the colors, but we believe from a greenhouse gas point of view, we're in a very favorable position. Right now, we're producing hydrogen continuously at the bench scale. Speaking to the elegance and simplicity of the technology, we went from initial concept to hydrogen production in about 6 months. We verified our reaction temperature model. We've got financial support from several significant partners within Canada, hydrogen producers and consumers. And right now we are in the thick of fundraising to build our demonstration plant, which will be around 200 kilograms of hydrogen a day. And we hope to have that out in the field for testing early to middle of next year. And that's us.
Andrew, thank you. And at this point, I'd like to open up the chat for questions for all of our presenters. So once again, you have Kathleen from NewWave Hydrogen, Gary from Ekona Power, Grace from Hydrogen in Motion, and Andrew, who just completed his presentation on Aurora Hydrogen. So any questions you might have, post them in the chat. Maybe you know, I can kick things off, I guess. Andrew, you were discussing the funding piece and just getting over the line, and I wonder if you can speak to you know, the availability of public funding opportunities, non-dilutive funding to support that next stage of development for your company.
Yeah, you know, our observation has been that from the, you know, public/private side, you know, it can be a bit tough and can for hardware development at, you know, for the TRL level that most methane pyrolysis technologies are at, and the check size that needs to be written to develop, you know, energy hardware. Basically, we're talking about high pressures, high temperatures. It's not inexpensive. So on the private side, you know, the risk appetite kind of seems to be a bit lower, especially compared to the US, just to be totally honest. On the other hand, you know, the non-dilutive really seems to be addressing that, we'll call it a market failure, and stepping in very, very aggressively, very in a very warm and friendly way to support the development of the technology.
Great, and I see a few different questions now have popped into the chat. Maybe I'll just ask that you indicate in your question when you post it, and I'll direct this at Nathaniel. If you wouldn't mind just clarifying who you want to point that question to, and I'll pass it around. But in the interim, Grace, you cut your presentation short to give us a bit more time. Maybe I'll put the same question to you. How would you contrast the availability of public and private capital to support commercialization, given your sort of multi-year effort to do this?
Well, I think capital has been spoiled in the last 20 years by investing in software, and there's many funds that have sort of a $2 million check size and they'll expect you to get to market with that. Sorry, my help desk is here. And for that $2 million, you're paying, you know, a team of people with throwing a grilled cheese sandwich, working in their mom's basement, and they can get you something in market in 6 months or a year and a half. But hardware is fundamentally different, as Andrew was saying. We're 10 times that scale. And so there's a disparity between TRL levels and check size. And these funds are very somewhat inflexible because they have their own mandate and they have TRLs that they're looking for. So it's hard to have, it's a mismatch between the technology and the check size. That's the fundamental issue in the cleantech scale up in Canada and around the world. And I think the funds are starting to get their head around that. Governments are also turning on. Climate change is a disaster that we can really no longer avoid, given the huge swings in weather events every year. My insurance, I'm the president of the Condo Corp. Our insurance has tripled. So from $65,000 to $230,000 a year. Why is that? There's instead of one disaster every 10 years, there's 10 a year now. 10 a year. So someone has to pay for that, and that's why governments are accelerating their climate plans, because you can no longer ignore it. So we're in dire straits, I think, when governments have to have seen the writing on the wall. So hopefully the private sector will be moving towards that in the near future as well.
Terrific, thanks, Grace. Let me put a question to Kathleen, and then it'll come back to Andrew as well. So a comment around the challenge of methane pyrolysis, which is carbon management. So once you pyrolyze the methane, how do you manage the resulting CO2? Kathleen, are you having that issue, and what have you done to manage it? That's a question from Nathaniel Wage.
Well, we consider it a valuable or potential valuable product, although our cost models, we assume zero value for the carbon. If we do create a product from it, then that even increases our margins more. And it also uses, a valuable resource. So we separate the solid carbon, and we have designed a process to pelletize it and package it and distribute it to whatever end use we choose. We're looking at a range of different possibilities. Some of them are existing paths, and some of them are in R&D. One area that we're exploring heavily that we're very, very interested in is a type of land application that really kind of doubles the capacity of the carbon and the whole technology to reduce greenhouse gas emissions from the air in that case, and as well as other contaminants from runoff in water and fertilizers and such. Beyond that, in R&D, as most of you know, there's a lot of R&D in using carbon to produce nanocarbons or graphene or carbon fiber or other specialty products.
Thanks, Kathleen. And maybe a related question is around the energy intensity of pyrolysis. There's a few questions around thermodynamic efficiency and energy intensity associated with pyrolysis. How are you managing that piece of it?
Well, what's really fun, I think, about our technology is that we don't really require a lot of input energy. So we don't require a lot of electrical energy input. Because what we're using is we're leveraging the pressure that's already inherent in a pressurized pipeline. So that pressure differential is what drives the shock wave dynamics, essentially. As a high pressure gas enters into the rotating shock tubes that are arrayed around the drum, and we close the ports on the end, then you have a high pressure gas in a small volume tube that reflects off the end and creates the shock wave dynamics. So in our case, we believe that we sort of, in some ways, have a new energy source or a new energy paradigm that really relies on the shockwave dynamics to create the temperature amplification versus an outside source of energy.
Thank you. Let me put that same question over to Andrew around both the energy intensity and carbon management piece.
Yeah, sure. So maybe the easier one first on the carbon side. In our particular process, a lot of methane pyrolysis processes produce a carbon black, which is basically a nanoparticle. We're not doing that. We create essentially, you can think of it as a pellet or a larger carbon particle, essentially. And there are quite a few uses. We've been looking at some of the deeper markets. Soil enhancement, for example, is several billion tons a year of carbon. Steel making is several 100 million tons a year. As an asphalt additive, that's another application. So these are some deep markets, but really, long term, if we're talking about the volumes of hydrogen that are anticipated over the next 10, 20, 30 years, and frankly, depending on how the carbon price moves, probably the answer will be sequestration. And Alberta's fortunate. There's lots of old coal mines, quarries that need fill for reclamation. And if you think of the potential for coal mines that have now closed or are about to be closing to use existing workforce, existing equipment to put carbon back in for remediation exercises, I think there's a really good opportunity in that way. On the energy side, this is an interesting question because it really depends what you're comparing it to. Most methane pyrolysis technologies broadly are wildly less electricity intensive than electrolysis, for example. So, if you're coming from the point of we're making hydrogen, how are we going to go about doing that? That's one. If you're looking at compared to just burning natural gas, yeah, it's going to be more energy intensive than that because there is still, like molecularly, there's still residual energy in the carbon. So if you're not burning the carbon, then yeah, there's going to be some energy left over and it will be less efficient than processes that emit a whole bunch of CO2 inherently. But I think if we're talking about how are we going to produce hydrogen in an energy efficient way, I think methane pyrolysis definitely has a lot of advantages over other options.
Thanks. Let me put the same questions to Gary. Ekona's been at this and has made some quick strides. Maybe you can speak to both of these issues.
Yeah, I'd be happy to. Thanks. I'll take energy first. Very good question. It's so important to understand that part. And let me just sort of start at the beginning. We derive the energy for our pyrolysis broadly from the methane itself. So the pyrolysis energy is coming from the combustion of methane in an oxidant. And, you know, in theory, that's 75 kilojoules per mole of methane. And then you got your inefficiencies there. We do require some electricity for the parasitics, the compressors and the things that are part of our system. But that's not that much. It's like 2.4 kilowatt hours per kilogram of hydrogen, which when you compare that to plasma pyrolysis and then electrolysis, these numbers are much, much higher. So we're very electricity light, and therefore we're not super reliant on the electricity that we connect to. On the efficiency discussion, you know, we're producing hydrogen and carbon carries away from the process an awful lot of energy. So a lot of the energy in a methane molecule is in the carbon, and then the rest of it's in the hydrogen. So we're producing, you know, for every kilogram of hydrogen we produce, we're producing, what is it now, 3.8 kilograms of carbon. And so a lot of that energy is leaving the system through carbon. And, you know, we're roughly about 50% energy efficient because of that. That being said, the hydrogen available to us that we can extract from that methane molecule, we're extracting more than 90% of it. So it depends how you look at efficiency. Are you looking at it from an energy point of view or from the availability of the hydrogen you're trying to process? That being said, that carbon does carry energetic value, and maybe more importantly, it carries economic value. And, you know, we don't just want to bury it. I will say that our first intent, however, is to bury it. When we deploy our pilot, we want to make sure that carbon can be sequestered properly and safely. And so the first step for us will be to work with logistic partners to deploy carbon sequestration. And when I say carbon, I mean carbon, not CO2, properly into landfills, sludge pads, that sort of thing that industry can provide us, and show that these processes exist, can be handled at scale and then deployed. And I think our partners want to have that assurance that that is a viable pathway. That being said, we want to extract value from that. And I'll say a couple of things. Hydrogen market is much bigger than some of these high value carbon markets like carbon nanofibers and, you know, tennis rackets and fishing reels. We need to build large ubiquitous markets for carbon that can be commensurate with the scale of hydrogen as an energy commodity globally. And so I'm very much an advocate for some, you know, new market development in some, you know, areas like, and I've heard some of this already, you know, asphalt production, concrete production, land remediation, water filtration, where the value for that carbon may not be as high, but its deployment will be highly ubiquitous and scalable. And so we're pursuing those sorts of pathways with partners, and obviously have a long way to go, and always looking for good partners to collaborate on that side of the fence with. So thanks for letting me speak.
Yeah, thanks, Gary. And maybe I'll put one more question to you, which was posted in the chat. And it was really around, what else do you want to see government do to make the pathway easier for you to build your venture in Canada?
Yeah, well, thanks. How do I even begin? First of all, I will say we've been very well supported by government, and our partnerships there have been excellent. So always grateful to start with that statement. One thing that I think will be very useful for us as a hydrogen production company is to bring standards and, you know, levelize the playing field for hydrogen grid injection in the natural gas network. Our natural gas distribution and transmission companies across Canada are struggling with how to decarbonize that infrastructure. Certainly have mandates to do so. I think broadly looking at hydrogen as a pathway to do that, but have a variety of different marching orders in terms of what constitutes renewable gas. And I think what we need is a national standard. I don't know, maybe I'm being a little silly here, but a national standard for what a renewable gas in our network looks like, not just provincial perspectives, but a national perspective. And then national standards for how to inject that hydrogen into the network. And with that, developers can start to work towards those standards. That'd be one thing. I'm sure there's many more, but I'll stop there.
No, I think that's a great challenge that we at CRIN can bring to perhaps the SEPA Foundation and other partners through our network. Andrew, I see you've raised your hand. How would you answer that same question?
Yeah, just one thing to build on that.
Check?
Framework for solid carbon disposal. Framework for carbon credits for solid carbon sequestration. Like that's very high on our list. I mean, the CCUS framework is much more mature. We understand there's not a lot of right now because there isn't high volume industrial production of solid carbon to be sequestered, but getting started on a framework for that would certainly make us feel a lot more comfortable.
Awesome. Grace, let me put the same question to you. Is there something that government could be doing that would make your work easier right now in terms of the more efficient transport of hydrogen?
I think we need a cohesive strategy of how to fund and integrate the hydrogen supply chain. So of your speakers, you have 4 out of 5 are about production. I'm the only one who's doing storage, and there's no one who's doing applications. So there's a disconnect between supply and demand. It's not like a computer where you can just buy a computer, plug it in the wall. When you want to deploy hydrogen, you have to bring the whole supply chain to the table, including generation and distribution and refueling your tanks. It's the entire problem that you have to solve. So we have to create a policy so that hydrogen can be deployed in Canada in an efficient manner. And we have to recognize that a massive amount of new technology, hydrogen-based, comes from Canada. So we're real leaders in hydrogen, and we should take advantage of that.
Terrific. Thank you. Well, let me put the same question to Kathleen. You're familiar with the markets on both sides of the border. Maybe you can speak a bit to what might make things easier in Canada.
Well, I think the other speakers had some great answers. So I'm stuck to really add a whole lot more. I agree that we have been extremely fortunate in the funding that we've received, and are very, very grateful for that. And we are currently applying for additional funding in Canada. So I would say the speed of awards and the speed of payments, actually the cash flow awareness, would be very helpful to entrepreneurial startup companies to have a little more flexibility and speed in payment. But that's sort of a micro condition. On the macro, more facilitation and support in scaling up to active pilots, getting there faster would really be beneficial.
Thank you. And again, I'll draw attention both to Unique's program and offering that support to first deployment, as well as Foresight's new pilot program for other applications. I guess with that, we've covered a number of really great questions, and I see that there are no other questions in the chat. So I wonder if now would be a good moment to enable the breakouts. So our concept here would be that each of the entrepreneurs will host a breakout, and I believe that Jan will be able to join us as well and host a 5th breakout. So let me just confirm that Jan, you're available and able to join us.
Yes, indeed. Astrid said that she will do some magic to allow that.
Terrific. And so just a comment on how this will work. So next slide, please. So you'll see here that each of you will have the opportunity to select a particular breakout, which will be posted to you. Of course, Jan will handle the allocation of our host to each of the breakouts, but you'll be able to jump around wherever you like just by using that pop-up menu. I think we're all familiar with Zoom at this point. So with that, let me ask any questions people have, please post those in the chat, and I can help direct you, or both Astrid and Lee can help direct you if there's a challenge. Otherwise, you should see a pop-up now from the 3 buttons under More in your window. offering you the opportunity to join a breakout. And with that, we can step out. We'll just welcome everybody back. Thank you so much for rejoining us. Once again, I'd like to thank both our terrific panel, Brett and Jan, who kicked us off with such a great presentation. Of course, you can reach out to them for more details. And then Jan, thank you for jumping into hosting one of our breakouts. And I trust that, well, I can see there were a lot of people very interested in follow-up, so I hope for yourself that was useful investment of time. Lastly, I'd like to thank our the other four SME presenters, or solutions providers. And I would encourage everybody to just take a moment to rate the event with the poll that Astrid has shared. Astrid, how did they access the poll, or has it been sent to everybody?
It should be here on Zoom. If you don't see it, it may be in a button at the bottom of your screen under polls.
Super, thank you. So yeah, please take a moment to click on the poll. And last, a reminder that this event has been recorded, so we'll be able to share it with everybody. Hey, that's great. Nice to see. I'm sure you may have some comments on how we can improve. We'd obviously be very grateful for those, and you can email me directly at that email there. Yeah, let me just say a quick thank you to our panelists, to Grace Kwan from Hydrogen in Motion, Kathleen O'Neill at NewWave Hydrogen, to Gary Schubach at Ekona, and finally to Andrew Gillis from Aurora Hydrogen. Thank you so much. And of course, I'd encourage everybody to reach out to them separately. I understand there were a number of investors on the call. I would encourage you as well to reach out. And finally, stay connected with us. Take a moment to sign up for the newsletters and other information you can access through Foresight. And with that, I think we are a wrap. Thank you so much for joining us today.